This is quite possibly the hardest bounds question they could ever ask you in your GCSEs. They even tried to include pendulums in this. Is this physics or maths? Well, physics is applied maths, so all physics is maths anyway. So, this is maths. It says the time period t seconds of a simple pendulum of length L centimeters is given by t equals 2 pi root L over g. Dive uses a simple experiment to try and find an estimate for the value of g. G representing gravity, you don't need to know that. He finds L is 52, correct to 3SF. So a pendulum is basically something that does this. Yeah, so a pendulum. So L is 52, correct to 3SF. And T equals 1.45, correct to 3SF. Find the upper and lower bound of the value of G. Okay, so the first issue here is that this is not rearranged for G. Usually, when we do bounds, it's rearranged for the value or the variable that we're trying to find the upper and lower bound for. Unfortunately, that's not the case, okay? So, we are going to have to rearrange for G here. Okay, how do we do that? Now, the first issue is that there's a 2 pi in front of this whole expression that involves G. So G is hidden within the root. Let's just get rid of this 2 pi to try and expose it. So that 2 pi is being multiplied, right? So we're going to divide by 2 pi, and it's going to come to the denominator. We're doing t divided by 2 pi. So t divided by 2 pi is the root of L over g. The next thing is that g is obviously hidden within the root. So we're going to have to square both sides in order to expose g. Okay. Now when we square both sides, we could leave our answer like this. Yeah, because square is going to cancel root. But in terms of what we want to do later, I feel like I just want to square everything. Because we're going to have to reciprocate as well. So I think squaring everything, so we get t squared over 2 squared, which is 4. Then we get pi squared is L over g. G being in the denominator, no good. We're going to reciprocate. So we get g over L is 4 pi squared over t. And then finally we're going to multiply through by L. So there you go. G is 4 pi squared times L over t. Now they want us to find the upper and lower bound of G. Now, if I want G to be as large as possible, gub. If I want G to be as large as possible, do I want L to be big or small? Because remember what's happening here. L has been rounded. It's been rounded to 3 significant figures. So we're thinking about what are all the values that could possibly have rounded to 52.0 correct to 3SF. All right. Well, here's 52.0. We rounded to that first decimal place. You have things like 52.1. You have, what would this be? 51.9, 51.8, etc. 52.2. And you're just thinking, okay, well, this would have rounded to this. Yeah, this would have rounded to this. But when students think about this, they make the mistake of this being 0.0. They actually think it's been rounded to 1 decimal place because they think, all right, 0.0, you don't actually need the 0.0. But that's actually not true. For them to have said 0.0, they were actually using this digit here to round. And there's another issue with this. These actually do not round to this, to 3SF. 51.9 rounds to 52 to 2SF. So actually, this is all wrong. Another mistake that students make with this one. It's actually 0.1 and 0.2. Yeah, these round to 52.0. And this one would be 51.9. What would that one be? You're minusing 0.05. So when you add 0 and you're minusing 0.05, you're getting 51.95. So 99, 51.99. Then you have 51.98. Okay? So that's what's going on with these numbers. All right? Now you're thinking, which of these numbers would you choose to make this as large as possible? Sorry. So which one of these numbers would you choose? I haven't written all of them, by the way, to maximize this. Well, you would want L to be as large as possible. Yeah, you want L to be large, and you want to divide by something really small. So you're thinking, out of all this, what is the largest value? What's the largest value which would still round down to 52.0? Now, some of you might think, oh, it must be 52.04. That's not true, because I could add a 9 here. And that would still round to 52.0 to 3 significant figures. I can keep adding 9, 9, 9, 9, 9, etc. Okay? So actually, it's 52.05. All right? So I'll show you guys how we work out the upper and lower bounds after. But the upper bound is 52.05. Okay? But if we were to write it as an inequality, we can't say it equals 52.05. But that's still the upper bound because of all these lines that come before it. Okay? But then that's the kind of theory behind it. I'll show you guys how we calculate them super quick. So basically, in a nutshell, if I want gub, I'm going to do 4 pi squared. Then I want L to be as large as possible, lub. Then I want T to be as small as possible, lower bound. Then the other way around, G lower bound, I have 4 pi squared, that can't change. But I want L to be as small as possible now. Yeah, I want to take a small number and I want to divide by as large of a number as possible, tub. Okay? Now, how do we very quickly work out the upper and lower bound? So for L, which is at 52.0, I think we'll have space for this, but I could do it here. So L, which is 52.0, what you do is you just add another 0. Yeah? And then you added minus 5 to the last number. So the upper bound will be you add 5 to that last number. So you can think of it as 0, 0, and you're adding 5 to that units column, 52.05. Then your lower bound, you're minusing 5. You could think of that now as 200. When you minus 5 from 200, you get 195. So 195, 5, 195. But remember, you have that decimal point. So 51.95, which is what I had those valued over there. Let me just see that. You can see that. Yeah, let's go. So T, tub. Let's do the same thing. So T is 1.45. Add a 0. Yeah? So my upper bound, add 5, 1.455. My lower bound, minus 5, 50, minus 5 is 45. So we get 1.445. Okay, you guys can still see that, yeah? Yeah, let's go. Okay, so let's sub them in. Without having to write a whole new thing. Nah, screw it. So 4 pi square. Lub, where's lub? Lub is this one, 52.05 over tlub. Tlub is 1.445. I'm going to tick these off just to make sure I've used all of them. Then we have 4 pi squared, lb, which is 51.95 over tub, which is 1.455. Okay, I've used all of them. Let's type this in. So we have 4 pi squared, 52.05 over 1.445. I get 1422.04 0.042655. And then for my lower bound, also, am I forgetting something? I've forgotten that it's t squared, am I? Hey, I thought the numbers weren't working out properly. So that's t squared, t squared, t squared, 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 squared. Hey, yo, t squared, 4 pi squared. I was thinking this number's way too big for g. So just making sure, just double checking out t squared over 4 pi squared, L over g, 4 pi squared over t squared times by L. Yeah, that looks good now. Let me actually square that denominator. 984. Okay, looks a little bit nicer. 984. 1125639. And when I change that around, I get 51.95 over 1455 squared. 968.7669227. I think you guys can see that. Yeah, let's go. That is it, guys. If you learned something today, just remember to maintain your squares, innit? But yeah, I'd really appreciate if you hit the like button, subscribe for more maths content. If you guys want to join the Lung Gang Reddit to submit your own questions, link is in the description. And if you're interested in my GCSE courses, then feel free to check out the link in the description. See you guys in the next video. Nice.